Hello, Numberphile. My name is Jake, and I would like to talk to you about pi. But not pi as in 3.1415 and so on that we've all come to know, but a special case of pi when pi is equal to 2. Now, I'd like to talk about this when we use pi coming from a circle as its definition. So we'll take our circle and we'll define its diameter as d, and then we'll define its circumference as c. And we know that pi is defined as the circumference divided by the diameter. So let's say that pi equals 2. Then what? So pi is equal to the circumference divided by the diameter, which we are saying is equal to 2 in our special case. So this would mean that the circumference is twice the diameter, and then that half the circumference is equal to the diameter. But wait a second, what does this mean? This had me up all night thinking about it, and I had a lot of trouble sorting it out. So we have here half the circumference is equal to the diameter. So we'll draw those out. We'll draw out half the circumference here, and we'll draw out the diameter there in red. And what this is saying is that these two are equal when pi is equal to 2. Now, personally, I find this a bit shocking. So we'll look at first the arc length of a semicircle, because that's an established formula that we can kind of work with, and it's defined as pi times the radius of the semicircle. So now in our case, we're saying that pi is equal to 2, and instead of having r, we'll have in half the diameter there. Then 2 times half the diameter is the diameter, and the arc length of a semicircle is half their circumference. So again, we come to half their circumference equals the diameter. But this seems a bit of a soft formula to work with, and I still feel a bit unsure. So I'm going to ask myself, can I do this with calculus? And I tried to do it in Cartesian coordinates, and to be honest, they broke my heart, and it did not work out. So I decided I would try polar coordinates because they seem a bit more friendly, especially when it comes to circles. So here we'll draw out our axes and our semicircle. We'll throw that on there. And then here, I've pulled out the formula for arc length. Now, because this is a circle in polar coordinates, r is equal to a constant, which means the derivative of r with respect to anything is going to be equal to 0, which will simplify our integral immensely. And then we can evaluate our integral. And we do a few steps, remembering that this arc length is the semicircle, so it's half the circumference, that this r is equal to half the diameter, and that we're saying that pi equals 2. And then we work it out, and here we can see from the calculus that half the circumference is equal to the diameter. And this is one reason why I love polar coordinates. And now we can keep adding these semicircles, and we can say that the length of this line is equal to that semicircle, and we can make them all look very wiggly and strange. So now, to me, this raises the question, does this apply to other curves when pi equals 2? And does the notion that a straight line is exclusively the shortest path between 2 points not apply when pi equals 2? And I was hoping you could make a video and explain it, or just some sort of explanation, and I'd be quite happy. And I've left you with a little comic to brighten up everyone's day.